Am I audible, sir?
Uh, yes, Sandeep sir, is it audible?
Yes, sir.
Okay, okay. Thank you, sir. So our resource person have joined. Sir, just 1 minute, then we will start. So we are going to introduce our next speaker, Dr. Sandeep Raj, member of IEEE. He received the BTech degree in Electrical and Electronics Engineering from Allahabad Agriculture Institute, deemed University, Allahabad, India in 2009. The PhD degree from Department of Electrical Engineering, IIT Patna, Bihta, India 2018. He received DST Inspire Fellowship Award by the Department of Science and Technology, Government of India for pursuing PhD. He is currently serving as an assistant professor with the Department of Electronics and Communication Engineering at NIT Durgapur. Prior to NIT Durgapur, he was serving as an assistant professor at IIIT Bhagalpur, India. His research interests include biomedical signal processing, embedded system, machine learning, Internet of Things. Thank you, sir. Over to you, sir. Please, sir. You may proceed, sir.
Thank you for the introduction, sir. So, today's topic of discussion is AI-based disease detection in crops. So, before moving to the details of the presentation, I would like to just brief some of the points. Like we want to basically detect the uh, different kind of diseases in different crops using AI, or more precisely, the machine learning and the deep learning techniques. And I will just have a glimpse that uh, we will develop how can we can integrate an ML software with the backend and forehand, and we can develop an Android app for farmers. So what will happen in that app is that we can upload the image of the crop, and then after we can detect the different kind of disease if available. If not, then the leaf will be considered as normal. And if the model detects some diseases, then proper recommendation can be also sent on WhatsApp. So this is a part of my project at IIIT Bhagalpur, which we jointly did with Bihar Agricultural University Sabor. And in collaboration with BAU Sabor, we were sending the recommendations for the different kind of diseases that was being detected by our AI model. So let us have some of the introduction that why I have chosen this area, AI in agriculture. So India is one of the major players in agriculture sector worldwide, and its primary source of livelihood for about 58% of Indian population. India has the world's largest cattle, and the data I am provided from IC here, manual. And the largest area planted to wheat, rice, and cotton. India is the largest producer of milk, pulses, and spices in the world. India is the second largest producer of fruits, vegetables, tea, farm fish, cotton, cane, rice, and sugar. Agriculture agricultural world.
Sir, your slide is not changing.
Okay.
Sir, your slide is not changing. Yes, sir, right
Okay.
now it's
Now
visible.
it is changing.
Yes, sir, right now it is
Okay.
visible.
Okay. Okay. Thank you. So, let me do one thing. Let me share the complete screen. Now it is visible. Hello.
Sir, not visible yet.
Now it is visible.
Yes, sir. Right now it is visible.
Okay. Thank you. So agriculture sector in India holds the record and second largest agricultural land in the world, generating employment for about half of the country's population. So the farmers are an integral part of this to provide
Sir,
sustenance.
I think you are having some network issue because your voice is also breaking and the slide is partially visible. Yes, sir. Right now visible, but your voice is breaking, sir.
Okay. Okay. I hope now it is clear.
Yes, sir. Right now it is clear. You can proceed, sir. Yes.
Yeah.
Thank you,
So
sir.
consumer spending. Yeah. Thank you. So consumer spending in India will return to the growth in 2021 post-pandemic led contraction, expanding as much as by 6.6%. According to the INC 42 media, the agricultural sector is slated to increase to the US $2,400 billion by 2025, and Indian food and grocery market is the world's sixth largest with retail contributing 70% of the sales. As per the first advance estimates for financial year 22-23 for the Kharif crop, total food grain production in the country is estimated at 149.92 million tons. Rapid population expansion in India is the major factor driving the industry. So the rising income levels in the rural and urban areas, which has contributed to an increase in the demand of agricultural products across the nation, provides an additional support for this. So in accordance with this, the market is being stimulated by the growing adoption of cutting edge techniques like blockchain, artificial intelligence, geographic information systems, drones, and remote sensing technologies, as well as the release of e-farming applications. So several applications have been developed, and if you will visit on the Google Play Store, you will find that Germany has developed uh, an Android app, namely Plantic, which does the same thing. It detects the diseases in different kind of crops. But as we will move forward, we will see that the measures what we have taken is for the 10 major crops of Bihar, and we have collected the data from ground to develop this app. So, what are the different problems that are being faced by the farmers? Farmers need to deal with many problems, including how to cope up with climate change, soil erosion, biodiversity loss. The effects of the climate change affect farmers' ability to grow the food we all need. Increasingly, volatile weather and more extreme events like floods, droughts, changing growing seasons, limited availability of water, allow weeds, pests, and fungus. They reduce the crop productivity. So, what we want to, what our measures can help the farmers is to satisfy the consumers' changing taste and expectations, meeting rising demand for more food of higher quality, invest in farm productivity, adopt and learn new technologies, stay resilient against global economic factors, inspire young people to stay in rural areas and become future farmers. So, what are the different challenges? So among the several challenges of small and marginal farmers, Losses due to pests and diseases are the major concern. It is estimated that about 40% of the global agricultural production is lost due to pest and disease attack. Further, climate change increase and indiscriminate use of pesticides have increased cost of production as well as has made crop production highly unpredictable. There is a need to develop a holistic crop health diagnostic services and community-based pest and disease management module to ensure site-specific need-based pesticide application to develop a sustainable and climate-resilient crop production module. The technological advancements has provided an array of new generation of technologies which can be employed for accurate diagnosis of pest and disease over a large area, providing accurate farm advisories. So there are different technologies that has been brought to the farmers like weeding robots. These are the smart agri robots that use the digital image processing to look through the images of weeds in their database and to detect similarities with crops and weed out or spray them directly with the robotic arms. So with the increasing number of plants becoming resistant to pesticides, they are a boon to the environment and also to the farmers who used to spread the pesticides throughout the farm. An estimated 13,000 kilograms of herbicides are applied at cost of 1,725 crores each year, thus reducing their overall cost. So what I am trying to say is if we can develop such kind of AI model and we can integrate with some robots, then the total cost of productivity can go down. So in practicality, there are several robots. Of them, one of the robot is the weeding robot. The second one is the machine navigation system. This is a remote controlled toy cars that are enabled with a controller. Tractors and heavy plowing in equipment can be run automatically from the comfort of home through GPS. So anybody sitting at the home can operate this. So a camera is integrated to the system and it can be sent to the land and it can be easily controlled through the different controllers. So these integrated automatic machines are highly accurate and self-adjust when they detect differences in terrains, simplifying labor-intensive tasks. Their movements as well as work progress can be easily checked on smartphones. With the advancements in IoT in agriculture and machine learning, these tech-driven motors are being enabled advanced farming using IoT independently with features such as automatic obstacle detection. These are the harvesting robots. So utilizing agri-bots to pick crops is solving the problem of labor shortages, working the delicate process of picking fruits and vegetables. And these machines can operate 24 by 7. So a combination of image processing and robotic arms is used by these machines to determine the fruits to pick and hence controlling the quality. Due to the high operational costs, crops that have an early focus on agri-bot harvesting are apples. Greenhouse harvesting also finds application with these bots for high-value crops like tomatoes and strawberries. These bots can work in greenhouse to aptly determine the stage of crops and harvest them at the right time. These are the different kind of robots. They are used in the agricultural sectors in the different countries. Coming to the drones part, the drones in agriculture are used to enhance and optimize the various farming activities such as crop monitoring, crop spraying, soil analysis, and mapping. In fact, agriculture is one of the major sectors to incorporate a drones. Are equipped with different kind of sensors and cameras which are used for imaging, mapping, and surveying farms. There are ground-based drones and aerial drones. Ground-based drones are bots that survey the fields on wheels, aerial drones, formerly known as UAVs, unmanned air vehicles or unmanned aircraft systems, are the flying robots. Drones can be controlled remotely or they are being flying automatically through software controlled flight plans in their embedded systems, working in coordination with the sensors and GPS. So these are some of the pictures of drone. Why I am showing this? Because while we were collecting the data or while we were preparing the data for the Bihar state, so we have drones. We have used drones to collect the data of different crops. So from the drone data, insights can be drawn regarding crop health, irrigation, spraying, planting, soil and field, plant counting, yield prediction, and much more. Drones can either be scheduled for farm surveys or can be bought and stored near farms where they can be recharged and maintained. After the surveys, the drones need to be taken to the nearby labs to analyze the data that has been collected and thereby helping the leverage IoT in the agriculture better. This is a remote sensing in agriculture, and basically the sensors are being used to measure the soil moisture, and we can develop a dashboard to see the different measurements of soil moisture at the dashboard, and proper action can be taken accordingly. So what can be done through remote sensing? That sensors placed along the farmers monitor the crop for changes in light, humidity, temperature, shape, and size. Any anomaly detected by the sensors is analyzed and the farmer is notified. Thus, remote sensing can help the spread of diseases and keep an eye on the growth of crops. Regarding the weather conditions, the data collected by the sensors in terms of humidity, temperature, moisture, precipitation, and dew detection helps in determining the weather pattern in farms so that cultivation is done for the suitable crops. Soil health analysis helps in determining the nutrient value, dried area of farms, soil drainage capacity or acidity, which allows for adjustment of the amount of water needed for irrigation and opting for the beneficial type of cultivation. So the soil health data can also help in leveraging the regenerative agriculture by providing insights in how and when to increase the organic matter and therefore achieve a better soil structure and eventually play a path for a climate smart agriculture. So at this stage, we are trying to develop the image processing part, the drones part, which is typically a concept of the IoT that it is taking the pictures and it is storing. We have prepared a database, and after preparing the database, we will apply the some of the machine learning or deep learning techniques. So integrating all this, we have uh, a new keyword is being generated in the today's world is the digital agriculture. So with the growing world's population and the demand for food rising, it is crucial to have used efficient farming methods to increase production on the limited amount of land. AI is becoming more prevalent every day in agriculture, and AI-based devices are elevating the current farming system. Agriculture is the dependent on number of variables including soil nutrient content, moisture, crop rotation, rainfall, temperature, and many more other parameters. So products based on artificial intelligence can use these variables to track the crop productivity. In order to improve a wide range of agriculture related tasks throughout the entire food supply chain, industries are turning to the artificial intelligence technologies. So weather forecasting using AI can be done. Farmers find it challenging to determine the best time to sow seeds due to climate change and rising pollution. With the aid of artificial intelligence, farmer can analyze weather conditions by using weather forecasting, which helps them to plan the type of crop that can be grown and when seeds should be sown. Another aspect of AI in the is the soil and crop health monitoring system, which is today's topic of discussion. The kind of soil and nutrition of the soil have significant effect on the crop that are being grown and their quality. The quality of the soil is deteriorating as a result of growing deforestation, making it difficult to access. And with the use of robots, we can use the just means robots can effortlessly carry out for the variety of different activities, and it can be integrated with AI to perform wide range of applications. Pest detection using AI, one of the deadliest enemies of farmers who cause agriculture damages are pests. AI systems employ satellite photos, historical data to determine whether any insects have landed, and if so, species or other pests have done so far. So AI aids farmers in their battles against pests by sending alerts to the cell phones so that farmer may take the necessary precautions and employ the necessary pest management. So let us have a brief discussion about what is AI. So basically AI consists of two words, artificial, which means man-made, and intelligence. So what we expect from this today's topic of discussion is we want to make a software or a model that can be capable of thinking like humans, as we can say that the different kind of diseases falls in the domain of plant pathology or entomology. So they are the experts and they study the different type of diseases in the crops and their proper management. So we want to develop a system or software or hardware so that our machine may be capable of detecting the different kind of diseases in different crops. So the basic idea behind AI is to make the machine capable of thinking like humans. Artificial intelligence is also known as the machine intelligence, and falls in the domain of computer science. Nowadays, the domain of AI explored in any engineering branches, in fact, in the business management also. So, in computer science, AI research is defined as the study of intelligent agents, any device that perceives its environment and takes action that maximize its chance of successfully achieving the goal. AI is applied in learning and problem solving. AI is now a part of our life, whether we know it or not, and whether we accept it or not. It has risen to such a status over the years in a slow but a steady manner. Everything that we do, buying clothes, shoes on the internet, as well as watching shows on TV, is being influenced to various extents by AI. However, the question that needs to be asked in this context is what effect would it have on education? So, in computer science, AI, sometimes called machine intelligence, demonstrated by machines in contrast to the natural intelligence, the term AI is used to describe machines that mimic cognitive functions that human associate with other human minds, such as learning and problem solving. The aim of AI is to develop intelligent computer systems in a form of a software or device that are being able to perform tasks without receiving any instruction directly from humans. AI works by combining large amount of data with fast iterative processing and intelligent algorithms, allowing the software to learn automatically from patterns or features from the data. So basically, there are three kinds of AI: the weak AI, the strong AI, and the super intelligence. So the non-sentiment machine intelligence typically focus on the narrow task. For example, the Google Assistant, Google Translate, Siri, Cortana. They are the examples of weak AI. They are all machine intelligence. They use the natural language processing. We are in the domain of strong AI or the artificial general intelligence, machine with the ability to apply intelligence to any problem rather than a one specific problem. And super intelligence is the artificial intelligence far surpassing that of the brightest and the most gifted human being. Due to the recursive self-improvement is expected to be a rapid outcome of creative artificial general intelligence. It means that perhaps after a few centuries we can have a machine capable of doing more than a human. So what from this lecture or the this topic we expect that we develop a model and we deploy it to the public either in the form of an Android application or a web-based solution, or we can develop a standalone software like Microsoft Office also. For the remote locations where the internet facility is not available, to such places we can deploy it either in the form of a device, dedicated device can be developed, or we can use the standalone software because the Android application and the web-based solution can be accessed using internet only. So for the remote places, we can go for the standalone or software or the hardware device. So the system must be a expert system capable of making decisions, and it should the forecast based on the previous data. So the game of AI is all about the data. So before going to the technical aspect of this, we have used the KVK, the Kisan Vikas Kendra officers for collecting the data for the 10 major crops of Bihar, of them potato, tomato, and many other crops. So I will just give the example of being detection of four crops only. So applications of artificial intelligence in the domain of agriculture, we can have the crop yield prediction and price forecast. So sometime what happens is the price of crop can be predicted after if there is a situation after flood or drought. So it can be done based on the previous data. Intelligent spraying can be done by using the sensors and the drones. So basically, sensors senses the data like soil moisture or what amount of nutrient is present in the soil, and based on the measurements taken from the sensor, the amount of whatever it is, either insecticide or pesticide that has to be sprayed on the ground can be done in a proper manner regarding the amount. We can have the different predictive insights that if some kind of flood can happen, like in our city, where I was earlier in the Bhagalpur, it was expected that every 3 to 4 years there can be a flood situation there. So agricultural robots can be deployed. Soil and crop monitoring can be done again using the sensors and robots. And today's topic of discussion is to detect the different kind of disease or the disease diagnostic part in the agriculture. So first of all, who wants to explore the area, they should know that from where to take the database. So there is a plant village dataset. I will be discussing it later, and the images have been taken from there. Basically, initially when we started the project, we have taken the online dataset, and since data collection is a long process, so in collaboration with the BAU server, we have collected the data from ground only, and we have made our own database for the Bihar region or the Indian state of Bihar. So the use of the motivation behind this work was the use of the unmanned air vehicles, machine learning, and artificial intelligence tool have become a practical and can be employed for various applications in agriculture. And the most important part is the cost factor. So the cost can be minimized using the AI or these emerging domains. So there is no solution available to detect automatically detect the pest and diseases infected crops and generate advisories. So based on the detection of the pest and either the pest is being detected in the crop or diseases, we were generating the advisories to the farmers on WhatsApp that the image is being uploaded on this date from this region. We were taking the longitude and latitude of the person who was uploading the image, and based on that our model was predicting the different kinds of pests and diseases, and based on that what recommendation can be done, that was being informed us by the officials of BAU server that for this pest or for this disease, this much amount of insecticide should be sprayed for next 7 days with this quantity of water or whatever it is. So the basic objectives of this work was the development of AI and ML module for the detection of pests and disease crops and automated system that must be capable of generating advisories based on detection, and development and integration of AI pest detection module to the Android application or some kind of a decision support system for its decimation. So some kind of machine learning techniques is also used in the domain. So machine learning is the subfield of AI that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So there are many machine learning technique like artificial neural network, support vector machine, k nearest neighbor, and many more. So the first challenge you will find after having the data will be that which method you should use, because you never know that if you have applied support vector machine or if you have applied artificial neural network. So based on what hyperparameters, which method will provide you the higher accuracy. So basically, the machine learning provides the widely used for the classification and regression tasks. So for publishing papers, what we do is I will deal it separately, the publication part, if somebody is interested. So machine learning again followed by the deep learning. It is again a subset of machine learning. It is a subset of ML that uses specialized techniques involving multi-layer artificial neural networks. It is computationally intensive, and some today's laptops are well equipped with the GPUs and specialized hardware. The examples of the deep learning are the convolutional neural networks, recurrent neural networks, and many more. There are other terminologies involved in this also. So now, just we want to have a brief workflow of the crop disease detection using AI. So again, the first step is to collect the data, or if you are using an online database, you can use it. So it consists of two parts, the training phase and the testing phase. So the first process, as you can see in both the training and testing phase, is the image pre-processing part. It is a crucial step that we must apply on the image. So if we have collected the data from different sources, like if the data is collected from a 5 megapixel camera or a 50 megapixel camera or a DSLR camera. So what we will find that the size and the quality of the image is going to change. And if you are preparing a database, then you should make sure that the size of image, the quality of image must remain same. So there are different kind of techniques to deal with the size. You can resize the image in the pre-processing part. You can apply different kind of filter. You can identify the noise and apply the different kind of filters like high pass, low pass, or band pass, or median filters, or different kind of filters are available for different kind of noise, and you can apply them for removing the noise. Followed by you can go for the image enhancement also. You can apply the histogram equalization technique, which is a standard algorithm to make the image more clear. Because if we are not applying the image pre-processing technique, then the next step is the feature extraction. So we are not going to uh, get the actual features of the image. It will be having some kind of noise, and which will finally, when it will be applied to any kind of classifier, then it will generate the false detection. False detection will be there, and the accuracy will be low. And that happens while we are publishing papers. What happens is, for a particular data set, we know the amount of noise, we apply filters. The rest of the thing, all of us applies. But if we are not aware about the data and what are the different sources of data, then we are again going to have as a result, we are having a reduced amount of accuracy. So after the image processing, there are different techniques for extracting the features in the image. So one step can also be done. We can also segment the image using different models. There is a YOLO model which separates the leaf from the background so that appropriate features of leaf can only be extracted. That is the main advantage of the segmentation part, because I will, for example, we can see that any image, that the region of interest, if the mouse is rotating, you can see that the region of interest in this image is only this part, the leaf part, and the background is not of interest. So we want to basically take the features of the leaf part only. So the segmentation stage will just separate the background from this image, and we will only have the leaf part. And then after, we are going to extract the features for the leaves of the crops or plants. Followed by the feature selection. So in feature extraction, there are different kind of techniques. Uh, since we are dealing with the images, so we can have spatial features, we can have transform domain features. There are many standard algorithms. Or finally, if we are applying the deep learning techniques, so automatically we will see that how CNN extracts the features at different levels of the image. So after the extraction of the features, if the size of the feature set is large, so we can use the feature selection techniques to reduce the different to reduce the size of the features, so that while training we can reduce the time complexity. Uh, there is actually trade-off between the time complexity and the accuracy part. So if you want to publish paper, either you can reduce the time complexity, means the size of the feature set, which is a crucial parameter, or you have to improve the accuracy. So these are the two major factors involved in all of this process. So then after the selected features are being applied to the any classifier, for example, in this figure, we have taken the SVM classifier, the support vector machine classifier. So based on the features, the model is being trained to identify the different kind of diseases. So as you know that we use the labels to test the image. So it is a kind of a supervised learning technique. So for the different set of crops, the labels were provided earlier, and based on that, the model is being trained, and then it is ready for the testing phase. So once the model is ready after testing, then again in the testing phase, it follows the same step, but after feature extraction, the image directly goes to the classifier for final prediction. And at last, it generates a confusion matrix on the test set. And then after we calculate the accuracy of our trained model, it is similar to what we study in a semester. And then after we give the entrance exam. So how much intelligent we are, it is uh, the exams or in the testing phase, as in the testing phase we see. So the amount, the CGPA actually tells us that uh, how much intelligent a student is. On a similar basis, we train the classifier on different data, and then after we calculate the accuracy of the trained model. So while you will be uh, following the steps, there will be several challenges you will find. First challenge you will find in the which is a standard problem in AI regarding the unbalanced data set. In the case of unbalanced data set, what you will find is for a particular category of crop, let's say the normal or the healthy rice leaf, the amount of the number of images is around, let's say you have 10,000, and for the disease part, you have around 500 to 1,000 images. So there is a huge difference between two different categories of the same crop. There means around 1 is to 10, or so there may be a problem in the training. There may a problem exist that the case of overfitting or underfitting may occur. So the solution for the unbalanced data set is, or the classifier may be biased also for a particular category of data. So why you are before the pre-processing, during the data collection part or preparing the database part, you should make sure that there should not be much difference in the different categories of the image data. So it should be. So there are different steps for doing that. The first one is the data augmentation. Either you can apply that or the smooth technique. So basically, it replicates both of these techniques replicate the data, and the number of images after implementing the method is almost same. So that after doing this, it avoids the biasness of the classifier model. So if somebody is interested in this domain, he or she can explore the plant village dataset. It contains 54,305 leaf image samples with 38 classes spread over 14 crop species and 26 diseases. It is developed with six augmentation techniques such as scaling. Scaling is defined as the zooming or contraction of the image. So if the scaling factor is less than one, then the image will the image will be contracted, and if the scaling factor is more than one, then accordingly the image is going to be scaled or technically larger, followed by the rotation. So what happens is while the object is being rotated, like if you are taking the image of any planet, and if it is being rotated by 2 or 3 degrees or 5 degrees around 1 second. So the moment you take the image, the object is actually getting rotated. So a rotation factor is also there. So you can also apply there noise injection, gamma correction, or the tone correction, image is being flipped, and color augmentation. These techniques were applied to the dataset to create a diverse dataset with different background conditions. Since the size of the image was different, we each image was cropped in standard size of 256 by 256 pixels in the RGB channel, and the sample of images for each category is shown later. The level of these images was annotated by a plant pathology expert, which was provided by the database itself, and their label name. And you have to mention. So these are the different kind of images you can see on the screen: apple, blueberry, cherry, grape, pepper, potato, raspberry. So there are, I think there are 14 crops and with 38 different kind of diseases. So here also you can find some of the like apple scab for the apple fruit, black rot disease is there, apple rust is there for potato, early blight. Then for the different kind of the fruits or the crops, there are different kind of diseases, and that is labeled itself, and it is provided in the database. So first part, what we considered is the image segmentation part, and here we can see that the original image, we have applied some of the filters like median filter to remove the noise. We have converted the image into the HSV image with the color coding model, and then after the clustering based technique, and the final image, what I want to highlight using this is it is quite necessary to segment the background of the foreground, which is the leaf part, because while you will be training the classifier model, what you will find that the background of similar images is almost same. So while you will extracting the features, what you are going to find is 30 to 40 or 50% of the features having this original image background will be same. So there will be not much focus on the leaf part. So it is quite essential to remove the background or to perform the segmentation on such images. So the second part is pre-processing part. And if anyone skips this part, it will again going to affect the accuracy of the model. So most of the models can't handle the missing values. Some of them are affected by the outliers, high dimensionality, noisy data. So by pre-processing the data, we make the data set more complete and accurate. This phase is critical to make necessary adjustments in the data before feeding the data set into the machine learning model. 80% of our work was involved in the data preparation because the data what we have collected was from on the ground. So then ensuring the data quality is also important for the work of machine learning. So the main techniques to apply in the data, making it more usable for our future work. So data cleaning can be done, sampling the data, data transformation or the imbalance such problems, such techniques can be followed. So one of the most important aspects of the data pre-processing phase is detecting and fixing bad and inaccurate observations from the dataset in order to improve its quality. So what will happen if you are using the image directly, then there is no problem. But if you are using the Excel sheet, so there may be a chance that you have to deal with the uh, null values or similar kind of values may be available in the Excel sheet. So data cleaning is quite essential for such values of data. So this technique refers to identifying incomplete, inaccurate, duplicated, irrelevant, or null values in the data. After identifying this issue, one will need to modify or delete them. The strategies that one should adopt on the problem domain and goal the project. Talking about the noisy data refers to the meaningless data in the data set. So noise, as we all know, the noise is defined as the unwanted information in the data. Incorrect records or duplicated observations. For example, if we imagine there is a column in the database for age that has negative values. In this case, the observation doesn't make sense. So one can delete them, the negation sign, or set the value as null. Another case is we need to remove the unwanted or the irrelevant data. For example, we need to predict whether a woman is pregnant or not. So one should need the information about their hair color, marital status, or height as they are irrelevant to the model. An outlier can be considered as a noise, even though might be a valid record, depending on the outlier. So in this part, actually, we have to identify the observations or the values which are relevant, which is not relevant, and we have to apply the different techniques. So one needs to determine if the outlier can be considered as a noise data or if we can delete it from the database or not. So the solution for such problems is a common technique for noise data is the binning approach you can also apply. You can also go for the filters, mean filter, median filters, depending on the type of values are present. Either you are loading the image or you are accessing the Excel sheet. So where one can first sort the values, then divide into bins, the bucket with the same size, and then apply a mean or median in each bin for smoothing purpose. And we can also apply different kind of filters based on the different kind of noise. So the noise comes from the source. So if different sources are available, we have to apply the different kind of techniques on the different kinds of data. So that has to be make sure. In the image enhancement step, the contrast limited adaptive histogram equalizer can be used. It is a simple technique for uh, making the foreground and background the histogram equalizer. So it operates on the small regions in the image called tiles rather than the entire image. The neighboring tiles are then combined using bilinear interpolation. Interpolation is a technique, interpolation and decimation. So basically, we are interpolating the different values, or in a simple word, you can say that we are adding more number of values in between the two discrete set of values to remove the artificial boundaries. And this algorithm can be applied to improve the contrast of image. We can also apply the CLAHE method to the color images for better observation and uh, improving the quality or the contrast or brightness of the image. So in the segmentation stage, we have used the YOLO model, which is a typically pre-trained model. And using the pre-trained model, we have segmented the different kinds of images. And finally, the feature extraction and the classification part. So I have just highlighted the deep learning method. So it consists of different layers, the input layer, the convolutional layer, the pooling layer, the fully connected layer, and the output layer. So in the convolutional layer are made up of filters, also called as kernels, that are being applied to an input image. The output of the convolutional layer is a feature map representing the input images with the filters applied. Convolutional layers can be stacked to create more complex models which learn more intricate features for images. Followed by the pooling layer, there are different kind of pooling methods also that can be applied, like average pooling, max pooling, min pooling. So pooling layer basically reduce the spatial size of the input, making it easier to the process and requiring less memory. Pooling also helps to reduce the number of parameters and makes the training faster. So there are two main kinds of the pooling operation, the max pooling and the average pooling. The next layer is the fully connected layer. The fully connected layer are one of the basic type of the layers in the convolutional neural network, where each neuron in a fully connected layer is connected to the another neuron in the previous layer. Fully connected layers are typically used towards the end of a CNN when the goal is to take the features learned by the previous layers and use to make them predictions. So there means you can find different kind of CNN models. So again, while you are making a project or while you are publishing a paper, so there may be a question from the professor or the reviewer that why not you have used the LXNet or VGG or the simple CNN. So there are more than I think 20 around different kind of CNN models, CNN architectures that exist today, and they can be explored. They have their own advantages and disadvantages. Like if you want to implement the same method on a microprocessor like Raspberry Pi, so you can go for mobile net. So there is a very long history of CNN. So each of them has their own advantages and disadvantages. So here we will, in the CNN training phase, here we will initialize the hyperparameters and the proposed CNN architecture. Then we will fine tune the parameters to improve the accuracy part, which is in the training phase, followed by the accuracy. So this is an image. On the left hand side, you will find an image having no background, and B is the first convolutional layer filter that is being rotated on the image, and the rectified output of the first layer is being shown in figure 3, which is highlighted in blue, and you will find that the features are almost uniform based on the quality of data, the data what we have. And in the D part, it is the image for the second convolutional layer filter. And based on this, it automatically means based on the architecture that you have developed or based on the hyperparameters, each layer extracts the different features and output of the features. And finally, the classification results highlighted here. So the bounding box indicates the different kind of diseases along with the probability of their occurrence. A bounding box technique is used in which represents the one type of disease along with its rate of occurrence. So the bounding box basically highlights the region where the disease has been identified with a confidence score that around 90% or how much percent of confidence it has been predicted into a particular class. So in the implementation part, as I have highlighted earlier, 256 by 256, the size of image was, and the basic model was trained to separate the normal and disease plant images. So these are the different parameters that the optimizer was used as. Adam, the 100 epochs were used, the batch size was taken as 16. So based on the, they actually can change based on the amount of data, based on the type of data, how much number of images you are using, or how much size of the image you are considering. There must be a problem probability that for faster training you may be taking the size of image as 128 by 128. So these parameters are fixed for a fixed set of data for achieving a fixed accuracy. So while you may increase the number of classes or while you can increase the number of crops for training and testing, these parameters is going to change. And finally, so in the training set for different crops, for one experiment, we after that we have extended the project for different crops also. So initially we have taken the 7 crops consisting of apple, cherry, corn, grape, peach, pepper. So the training set consists of a total of 4,900 images, which was quite low in the initial phase. And the testing set consisted of 2,100. So a total of 7,000 images was used to develop the model. And this is basically the confusion matrix which is being generated on the test set, and it is interpreted as the row part is the ground truth and the column part stands for the AI prediction. So this confusion matrix can be uh, interpreted as out of 80 images of a particular class, let's say healthy, 75 images have been accurately or correctly classified as the healthy, and 5 of them have been misclassified to another class. So this 75 stands for true positive, which is the total number of correctly classified events of a particular class, and false positive, which is the 5 number, the total number of misclassified events to a desired class. And the same interpretation goes for the different roles, which stands for different types of categories or the different classes of data. Like we can consider 0 as healthy, 1 as any disease, 2 as any different disease like black rot or smut. So in row 2, out of 405 images of smut, 388 are correctly classified into the smut, the disease part, and 17 are misclassified to the black rot part. So on the basis of these different parameters are being defined like true positive. So along the column, along the this diagonal, the diagonal elements are the true positive for the different classes. And if you want to calculate the accuracy of your AI model for different classes, so you will find that you have to add the diagonal elements by total number of testing samples. So that will give you the accuracy. So if you want to calculate the precision and recall, so the formula goes like true positive by true positive plus false negative. And for recall, or it is sometimes also known as the specificity part, So true negative by true negative for false positive. You can again go on changing the uh, this different type of crops, and you can calculate the different parameters, and you can calculate the different metrics like precision recall and F4, and you can check the training and testing accuracy, that what is the uh, how much curve it is having or not. So where there is a smooth curve or there is a much zigzag. So if you find that the curve is not smooth, then you are going to find that the model accuracy is going to change over different data sets. So these are the different results. So in the previous figure, the blue line stands for the training accuracy, and the blue dots which is coming from the higher, it stands for the training loss. So as you can see that the training accuracy from 0 is going on increasing. So the x-axis is the epoch and y-axis is the accuracy and loss. So the accuracy is getting constant over the 100 epochs, and the and training and both testing accuracy highlighted using brew and lead brine, they are getting constant over 100 epochs. And the training accuracy and training loss and testing loss, they are uh, decreased over the 100 epochs. So using the Gaussian process optimization also, the best value for the learning rate can be taken for fine tuning the hyperparameters. Further, as I have highlighted earlier, that while you are publishing or while you are making a project, there may be a question get arise by the committee supervisor or the reviewer, that why you have used only a particular technique, why you have not explored the other techniques. So to serve the purpose, you have to apply 3 to 4 techniques and compare them. So in this figure, ResNet 50, SqueezeNet, DenseNet 161, they all methods have been applied and compared to show that which is the best one. So you can see from the figure on the left hand side that ResNet 50 has reported higher accuracy around 89.9 in comparison to the rest of the models. The precision, and on the right it is the accuracy is around 99.2% by the SqueezeNet model. And finally, once the model is developed, then you can integrate it with the different technologies to develop either your app. Let me give you some brief about. So there will be a pre-trained model. So now, once we have developed the model, our objective is to deploy it for public usage. So I just forgot you to address one more challenge. What you are going to find out is the biasing, or the to check whether the model has been suffering with the overfitting technique. So one of the most common method to avoid overfitting is the cross validation technique. So you can go for 5 or 10 fold cross validation. So in the any and k fold cross validation. So whatever the value of k you will choose. So what happens in k fold cross validation is, let us have an example with 5 fold cross validation. So the complete data set is divided into 5 folds. So let's say we have the total number of images as 1000. So it will be divided by 5. So each fold will consist of 200 images. So what is going to happen is for the four folds, they will be trained and the fifth fold will be tested. And this step is repeated for all the folds. So for phase, let's say for phase one, fold one is fold one to fold four is being trained and fifth fold is being tested. Then after fold two to fold five, it is being trained and the fold one is getting tested. And similarly, it is repeated for all five folds. The accuracy is calculated for all five folds. And then after the accuracy is averaged to highlight the or to compute the accuracy. So two things that challenges is commonly faced by the researchers is regarding the amount of images which can be shorted out using the augmentation or the smooth techniques, and secondly is the avoiding the overfitting of the classifier, which can be typically done. There are several other more methods, but you can use the k-fold cross validation technique to avoid the biasing, the overfitting of the classifier. So once the model has been trained, it is deployed on server. So if you want to develop an Android app, how it can go is you can develop the front end and back end. So what we have did is we have developed the AI model in Python language. And for the development of the database, we have used the MySQL and PHP. And for backend and front end, we have used the Java and the XML. So this is the basic architecture, and you can see that on the right hand side, uh, the AI model, the trained AI model is been what we have trained and tested has been deployed on the server. The app, the client part, the image is being uploaded and it goes to the AI model. It matches with the database that has been prepared. And based on that, a WhatsApp message is being sent on the mobile regarding the name of the person, the location, the from which district you have uploaded the image, and then after the type of disease which is getting detected, and based on the type of disease being detected, the proper recommendation is also sent on the WhatsApp. So this is the complete architecture of how you can deploy an AI model for public usage. Followed by, if you want to develop a typical hardware for the machine learning or the deep learning technique, so you can go for the deployment for the Raspberry Pi model. You can purchase it from the Amazon or Flipkart. You can integrate a TFT screen of, let's say, 7-inch TFT screen is also there. And the same what a software integrated on a laptop will do on a similar basis. Uh, this Raspberry Pi can also can give recommendations on the same device, providing internet facility is there, or you can just use it standalone also. So a prototyping can be also done for the AI model developed. So we have developed both the software part and the hardware part for this project. And for the software part, the patent has been granted, and for the hardware part, it is pending. So database. So in this project, the essential steps were the database preparation, feature extraction, and the classification methods to detect and classify the plant and crop disease on leaf. So first of all, we applied the pre-processing technique followed by the histogram equalization technique to enhance the different images, having the potential to highlight the different features in the images, followed by we applied the convolutional neural network, which achieved an accuracy of around 96% and with a precision rate of 94.41%. And for publishing papers, it is quite essential that you highlight that your accuracy, what you have achieved, is more than the existing or the state of the art techniques. And again, to illustrate the performance of our or any model, several comparisons for different shapes and loss functions can be provided to emphasize the depth of the research. And these are the references. So this is just a layout of the Android app that we developed jointly for the with BAU Sabor for Bihar government. So it is available in both languages. It may be not working currently because there is a issue in the maintenance part, but it was working before 3 to 4 months earlier. So it has been, so it is in position to be given to the government of Bihar for implementation in the state. So I don't know what will be the future, but we have completed our part. So you can see that in the second page, after selecting the language, you can enter your name. Just you have to create your profile. You can enter your name, phone number, district, and the type of crop. And you have to click on the next button. After clicking on the next button, it will generate two buttons are available, the camera or the gallery. So once you will click on the camera, you can just click the picture of the crop and upload it. Or if you have pre-saved the images or it is available in the gallery, you can take out from there and upload. After uploading, you will get a message on the app that the image has been uploaded successfully and the recommendations will be generated after a few minutes. So after few minutes, you will find out that you will receive a message from WhatsApp that for the person such and such from this district has uploaded the image of this crop. This image is suffering from this kind of disease. You are suggested to just this amount of insecticide with 100 or 1 liter of water. With, you have to spray till in the future till the next day, 7 days or 10 days. So thank you for the session. If you have any questions, I would love to take an answer. Anyone from the audience part? Any question?
Anyone has any question? Thank you, sir, for the wonderful lecture, for bridging the gap between advanced digital system with the AI-driven crop management. So your discussion on this topic highlights the modern research meeting the societal impact as well. So thank you for this inspiring lecture. Sir, can you please turn on your video so that we can take a photo together?
Okay. I don't know whether the camera is working or not.
Sir, I think it is showing black. So.
Yes, sir.
Oh, okay, sir. No problem. Thank you, sir, once again.
Thank you. Thank you, sir.
Okay, thank you. Okay, thank you, everyone. Tomorrow we will start at the same time. So be join at the time and see you tomorrow. Thank you, everyone.